A fine day to everyone. This is Professor Maria Luisa Bainyo Salingay, inviting you again to join me in my short discussion on chemical reactions and balancing simple equations. Chemical reactions. There are types of chemical reaction. The first one is combination or synthesis. It is a combination of two or more chemical species to form a product, with the general formula A plus B to produce AB. For example, magnesium oxide plus carbon dioxide to produce magnesium carbonate. The second type is the composition or analysis. The compound is broken into smaller chemical species. The general formula is AB to produce A plus B. So this is the opposite of combination or synthesis. So for example, carbonic acid will decompose to produce water and carbon dioxide. The third type is single displacement or substitution. One element is being displaced by another element. The general formula is A plus BC to produce AC plus B. So for example, sodium iodide plus chlorine gas will produce sodium chloride plus iodine gas. The fourth one is double displacement or metathesis. Two compounds exchange bonds or ions to form different compounds. The general formula is AB plus CD will produce AD plus CB. For example, sodium chloride plus silver nitrate will produce sodium nitrate plus silver chloride. The fifth type of chemical reaction is neutralization. It is a reaction of acid and base to produce salt and water. So, base sodium hydroxide plus acid HCl will produce salt sodium chloride plus water. The sixth type of chemical reaction is precipitation. Two solutions of soluble salts are mixed to form insoluble solid. So the general reaction would be A plus soluble salt B to produce precipitate plus soluble salt C. The seventh and the last type of chemical reaction is combustion. It is an exothermic reaction. Oxygen combines with a compound C to form water and carbon dioxide. With the general formula, oxygen gas plus C to produce water and carbon dioxide. Let's go now to balancing of chemical reactions. We need to observe the law of conservation of mass. The first rule is start with a complicated compound and treat it as one. Never change subscripts. Second, balance first the atoms with the lowest number of compounds. Then third, balance last the atoms present in most compounds. It is usually oxygen and hydrogen. And the fourth, reduce coefficients to the lowest whole number. Let us start balancing simple chemical reaction. Number 1, iron plus chlorine gas to produce ferric chloride. If you have noticed, you have 2 chlorine atoms at the left and 3 chlorine atoms at the right. So you need to balance them first. So to make it even, you write coefficient 2 here. So you have even. So you have now 3 times 2, so 6 chlorine atoms with only 2 chlorine atoms at the left. So you need to balance the chlorine. So you add coefficient 3. So make 6 chlorine atoms now. Balance with the 6 chlorines at the right. Now, next you balance iron. Since you add 2 here for iron, so you have to balance it with coefficient 2 at the left. So this equation is balanced. So you check balance left and right. Iron, 2 at the left, 2 at the right. Chlorine, 2 at the left, 2 at the right. We go now to the second simple chemical reaction that we need to balance. It is number 2. The reaction of diethyl ether with oxygen gas to produce carbon dioxide plus water. If you notice, there are only 3 elements here: carbon, hydrogen, and oxygen. And you need to balance oxygen or hydrogen last. So we need to balance carbon first. There are 4 atoms at the left and only 1 carbon atom at the right. To make it balance, you add coefficient 4 in carbon dioxide, so you balance down the number of carbon. We go now to hydrogen. There are 10 hydrogen atoms at the left and only 2 hydrogen atoms at the right. So you need to add coefficient 5 before water to make it 10. So now you balance the number of hydrogen in both sides. Now you balance oxygen last. If you notice, there are more number of oxygen at the right because this is 5. 4 times 2 is 8. So 8 plus 5 is 13. So you need to have 13 oxygen atoms at the left. So you have to add coefficient 6 before oxygen. This is now 12 plus 1 is 13. So this is a balanced chemical reaction. So we check carbon, 4 at the left, 4 at the right. Hydrogen, 10 at the left and 10 at the right. And oxygen, 13 at the left and 13 at the right. The third chemical reaction is the reaction of acetic anhydride plus water to produce acetic acid. It is similar to chemical reaction number 2. You have only to balance carbon and hydrogen and oxygen. Again, you balance carbon first. There are 4 carbon atoms at the left. To make it 4 at the right, you add coefficient 2 before acetic acid. So you balance it now. Next, you balance the number of oxygen also. But then, you add already 2 coefficient here. So the number of oxygen is already 4. So you have to make it 4 here. And at the left. So this is 3 plus 1 is already 4. So you have to balance hydrogen now. There's no need to balance oxygen because it's already balanced. So hydrogen, how many hydrogen? So 2 times 4 is 8. So here, 6 plus 2 is 8. So it's already balanced. Balance, 4 carbon at the left and right, 8 hydrogen left and right, and 4 oxygen left and right. The fourth chemical reaction is the reaction of iron plus oxygen to produce ferric oxide. First, you have to balance iron. So there are 2 iron atoms at the right. So you add coefficient 2 at the left to make it balanced. But if you notice, there are 3 oxygen atoms at the right. To make it even, you multiply it by 2 here. So you add 2. So it becomes 4 iron atoms. So since there are 4, you multiply this also by 2. 2 times 2 becomes 4. So it's 4. It's already balanced. Now, you balance oxygen. How many oxygen at the right? So 3 times 2 is 6. So to make it 6, you have to write coefficient 3 before oxygen to make it 6. Now, this equation is already balanced. The fifth chemical reaction is the reaction of ferric bromide plus sulfuric acid to produce ferric sulfate plus hydrogen bromide. In this chemical reaction, you need to balance 5 elements. To remember that you have to balance metals first, followed by non-metals, then oxygen or hydrogen last. In this chemical reaction, there are 2 iron atoms at the right and 1 at the left. So you have to write coefficient 2 before ferric bromide to balance iron. By adding coefficient 2 before ferric bromide, you also made bromine atom 6. 2 times 3 is 6. To balance bromine atom, you have to add 6 here to balance the number of bromine on both sides. Next, you balance sulfur. There are 3 sulfur at the right, so you have to add coefficient 3 before sulfuric acid to balance the number of sulfur. In adding 3 here, you also balance the number of oxygen because this is SO4 and also SO4 here. So the number of oxygen is 12, 4 times 3 is 12, and same here, 3 times 4 is 12. And last, balance the number of hydrogen. There are 6 here and 6 here. Actually, the number of hydrogen, it is already balanced when coefficient 3 was added before sulfuric acid. The sixth chemical reaction that we are going to balance is the reaction of acetylene and oxygen gas to produce carbon dioxide and water. Again, you need to balance oxygen and hydrogen last. So we need to balance carbon first. There are how many carbons at the left? There are 2 atoms and only 1 at the right. So you need to add coefficient 2 before carbon dioxide to balance the number of carbon. Now next is the number of hydrogen. At the left is 4 and at the right is only 2. So you need to add coefficient 2 before water to balance the number of hydrogen. 4 at the right and 4 at the left. And oxygen last. How many oxygen at the right? There are how many? 2 plus 2 times 2 is 4. So there are 6. To make 6 oxygen atom at the left, you have to write coefficient 3 before oxygen to balance the number of oxygen. Now this chemical reaction is already balanced. That is all for today. If you have comments, feel free to contact me on the following medium of communications.